Hello, you wonderful people. My name is Steve Pollard, and we're going to start our Getting Started lesson, part 1 for Shed Math. Overview. This lesson will help prepare you to build your scaled shed. The concepts and skills you will master in order are how to measure length on a tape measure or ruler, how to choose and apply scale to reduce the designed shed size and still retain its relative shape, what are similar shapes and specifically what are similar triangles, and how to calculate the length of a triangle's legs using similar triangles and scale factors. The order of the lesson for part 1 is measuring length, applying a scale factor, and similar triangles. Now we're going to go into measuring length. The goal will be for you to be able to read on a tape measure or ruler length to the nearest 1/16 of an inch. The expectation and assessment will be after completing the lesson you will complete a short assessment demonstrating that you are able to read and write the length represented on a simple diagram representing a ruler or tape measure. There will be 5 questions and you will be required to record the correct measurement for all 5 questions. Now here's the technique. Count once, count twice. That's it. It's pretty simple, isn't it? Let me show you what I'm talking about. I'm going to go ahead and get out of this PowerPoint right now, and I'm going to go into a special program that I have and I'm skilled in called Key Creator. It's a powerful modeling program that I use in boat design. But we're going to go ahead and use this to talk about how to read and write a fraction to the nearest 16th of an inch. Now the technique we talked about was count once, count twice. Here I have a line, 1 inch in length. I segregated it into 16 different points. Now the technique that we use is called count once, count twice. We simply count the number on the top point and then count the number on the bottom. I know that wasn't very clear, but I'm going to go ahead and demonstrate. So let's say I want to determine what the value is, or what the fraction is, right there. Right there. First thing, count once. What I'm going to do is I'm just going to count along the top of the line. I'll go 1, 2, 3, 4, 5, 6, 7. That is 7 marks. So what am I going to do? I'm going to put the number 7 right there on the top. Come back. Now count twice. This time I count all of the tick marks. I have 16. So all right, 16 on the bottom. There's my answer, 7/16. I counted once across the top. I counted twice along the bottom. On the top, top number. On the bottom, bottom number, 7/16. Let's look at another example. And I'm going to blow this up a little bit more. Now, I want you to look at the scale that I have here. This looks much more consistent, or very similar to what you will see on a ruler or a tape measure. Notice the tallest marks right here, the next tallest, another a little shorter, and the shortest. This is very similar to a scale that you will see on a tape measure. And I'm going to move this up just a little bit. make it easier to work with. Now, Same technique, doesn't matter whether it's tick marks or points. I have a line. I have points evenly distributed across that line. First one says count once, it's on the top, so I'm going to try to count once across the top. But before I do that, I suppose I have to select a point, don't I? So I'm going to create a marker. And let's say we want to look at that point right here. Okay? This is the point we want. So now I'm going to count once, count twice. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I'm going to write the number 13 on the top. Then I'm going to come back up. I'm going to back up, and now I'm going to count across the bottom. Again, 16 tick marks, so that's my second count. And what I now have? 13 sixteenths. I'm going to do one more example on this line right here. I'm clear off what I wrote here. Let's say I want to use that point right there. Okay. Again, go through the same thing. I'm counting once across the top. I got 4. Gives me a 4. Again, across the bottom. Count here. Oops, back up. And like typical, at least on my illustrations, you have the number 16. Now, as far as I am concerned, that is an acceptable answer. However, most teachers, especially math teachers, will tell you to simplify or reduce that fraction. So when I reduce that fraction, I can also say that one-fourth is an acceptable answer. Okay? And here's the point. You notice I selected this mark right here. And if I look at just having those 4 marks, if I delete those lines, those lines, those lines, those lines, and I get rid of these, what do I have now? Just these bigger tick marks, right? I count once, counts twice. That's 1 over 1, 2, 3, 4. So that's 1/4 or 1/4. Now, this is just an illustration. Like I said, I will accept a non-reduced fraction as an acceptable answer because I'm asking you to find out what the measurement is to the nearest 16th of an inch. However, 1/4 is also accurate. I just want to point that out to you, and so that you do not get confused. So let's look at one more example. Now I'm going to blow out here. What do I have here? I have 4 inches. 1, 2, 3, 4. Each of these are inch marks. Now I'm going to ask you a quick question. If I put a circle right here, what would be the measurement there? It'd simply be 1, or 1 inch, and no fraction. That's all I would do. I would literally write the answer like this. 1, and then a quotation mark, because quotation mark represents inches. It's a common notation. And so my answer would be 1 inch. Because I'm exactly at the 1 inch mark, and I'm adding no fractions to it. Nothing beyond it. It's exactly at 1 inch. Now let's move beyond this. Oops, didn't want to do that. Now let's say I want you to give me a measurement at this intersection. I'm going to look right at that mark, and I'm going to look at that tick mark right there. What we're saying when we're looking at these tick marks is we're looking at, I have 2 whole inches and a part of a whole, or a fraction. So when you're looking at tape measure right here, I'm looking right here, and I come to the number, to the nearest to my left. So my nearest whole number is 2. So I have 2 inches and a fraction. If I was over here, I'd have 3 inches and a fraction. So when I'm writing a whole, or I should say a mixed number, where I have a whole number and a fraction, the first thing I'm going to do is I'm going to recognize my whole number. So the first thing I'm going to do is I'm going to type in the number 2, and I'm going to put it right there. Now I'm going into determining the fraction, which is just this portion right here, and I'm going to do my normal count once, count twice routine. So I'm going to zoom in on the 2 and 3 because that's all I'm working on. And I go through the same routine again. So I go through my counting routine. Oops, I won't do that. I'm counting the top, count once. 1, 2, 3, 4, 5. And again, I got to count the bottom. 1, 2, 3, 4, 9. So I come back up here, and what do I have? I have 5 on the top. I have 16 on the bottom. There's my fraction. Now I have everything I need to know the answer. I have my whole number. I have my fraction. So all I'm going to do is come over here, and I'm going to write this as 2 5/16. But let me do this. I'm going to show you something right here. Okay. I'm going to write this in proper notation. So this can be 2 5/16, and then I use a quotation mark because that represents inches. So my correct answer would be 2 5/16. I have 2 whole numbers, and 5/16 is my fraction. So 2 and a part, or 2 and this fraction. So my answer is 2 5/16. Now let's go back to our PowerPoint slide and continue on. Now we talked about the technique right there, right? About counting once and counting twice. That's it. Pretty simple. Count the ticks that you want to go to across the top, count the total ticks between the whole numbers, you get your fraction. Now, what I want you to do here is I want you to pause this video. I want you to watch the video titled Tape Measure Use, Markings, Fractions, etc. How to Read a Tape Measure by Scott C. Parker. When done, return here and continue the lesson. I'm going to wait about 5 seconds and continue on. Now, I just want to make a point here. Anytime you have a tape measure and you get beyond 1 foot, you can have this measurement right here, 6 foot. Or it might be 5, or 12, or 18, depending on the size of the tape measure. As explained in the video, you have different ways of reading it. Here on this tape measure, I read 6 feet, 2 inches, or 74 inches. What I want to do here is explain how to write it in the proper notation so people understand what you're writing. You can write a fraction larger than 1 foot 2 ways. In this particular example right here, what I'm looking at is 6 foot 1 3/4 inches. Now the first technique is write it as a foot in inches. The foot indicator is a single hyphen mark, which is this mark right here, or right here. The inches indicator is quotation marks, which is right there. So in this first technique, I would write the fraction as 6 foot 1 3/4 inches. The second technique is to simply write the total inches, so it would be 73 3/4 inches. Now I'm going to talk about this again as we get into actually scaling your parts. But whenever you're dealing with scale and multiplication and whatnot, it's always much easier to stay with 1 unit. So you're dealing with all feet, or all inches, or all centimeters, but deal with the same unit if at all possible. It makes things much simpler. So in the context of everything that I'm doing, I'm choosing to use just inches. So if this was a particular measurement I would use, you would see me saying 73 3/4 inches or 73.75 inches. That's just a point to remember that it's always easier to deal with one type of unit. So you do not have to deal with conversion. Now, I want you to do some practice. I want you to pause this presentation, work the problem. Write down the length to the nearest 1/16 of an inch. Place is indicated by the small red circle. I'm going to wait about 5 seconds and then move on to the solution. Solution. Count once across the top gives me 6. Count twice across the bottom gives me 16. So acceptable answer would be 6/16. Or if you reduced it, it would be 3/8. Let's look at another one. I want you again to pause this presentation, work the problem. What is the length measurement at the small circle? Right there. Pause, work the problem, come back. I'm going to pause this presentation for 5 seconds. Solution. We're dealing with the mixed numbers. I'm going to be zooming in on this point right here so we get a larger number. I got this point right here, right at the 1. So as I explained earlier, the first thing is we recognize what the whole number is. The whole number is 2. So it's 2 and something. Step 2, we use our count 1, count twice technique. Count once across the top. Oh, it's at 1, so my top number is going to be 1. My bottom number is 16, so my answer is 2 1/16, and I forgot to write it in notation. So there should be, I could drop the TH and put quotation marks here if I wanted to. and more. Oh, sorry, that was it. This concludes the lesson on measuring length. Prior to moving on to the next lesson, complete the measuring length assessment included in this unit and submit it for review. You can either pause the tape and do it now, or do it at the end of part 1. But it is important that you work through it and make sure that you understand how to read a tape measure before moving on to part 2. Lesson on scale. What is scale? Scale objectives. Student will understand how to apply a scale in order to reduce the length of shed parts according to their selected scale accurately. Students will cut all of their framing, paint, stir, sticks, or other wood product to the correct length and label each part so that every part is clearly identified, what it is, and where it goes in the shed. You will have to apply a scale factor to the drawing of a shed I am providing to generate smaller parts. Scale is simply a way of uniformly reducing or enlarging an object while maintaining the same basic shape. In other words, the scaled objects, if you apply the same scale correctly, will be similar. We will discuss what similar shapes mean after we understand applying scale. After the lesson, you will determine the scale size of most of your scale model shed parts. Reductions and enlargements. Applying a scale factor. I would like you to watch the video titled Reductions and Enlargements. The author is Australian and speaks with an accent that makes it a little difficult for those of us in the United States to understand. So you need to listen carefully, and if you need to back up and listen again, please do so. It is a very good video, and the instructor does a good job with using scale to enlarge or reduce objects, which is exactly what you will have to do. Please pause this presentation now and watch the video. I'm going to continue in 5 seconds. Now that you have a pretty good idea how to do a reduction or enlargement using scale, let's talk about similar shapes. What are similar shapes? Here are the objectives of this lesson. Students will understand what it means that shapes are similar. You will be able to recognize through visual observation if an object is clearly similar. Sometimes you won't be able to tell, but if it's clear and easy to understand, you should be able to identify it right away. Students will apply their understanding of similar shapes when calculating the rafter lengths of the actual and the scale shed. In your project, you're going to need to calculate the length of your rafters. To do this, you will need to understand scale factor and similar shapes. There are 3 videos that I would like you to watch on the next slide. Please watch them in the order listed, as each has a unique twist that adds clarity to the previous videos. Watch these videos in order, please. Difference between similar and congruent figures by Mashup Math. Solving for Scale Factor by Raquel Borges, probably mispronounced her name. And Finding Scale Factor Big to Small and Small to Big by Alan Lopez. Please pause the video right now, watch the videos, those videos, then come back to this presentation and continue. I'm going to wait for 5 seconds and continue. Conclusion to Getting Started, Lesson Part 1. This concludes the first part of Getting Started lesson. We discussed measuring length to the nearest 1/16 of an inch, what is scale, what are similar shapes, and how to use a scale factor to find the lengths of similar triangles. What is next? Getting Started Part 2. In order to build your shed, you will need to calculate the length of your rafter. In Getting Started Part 2, we will learn about the Pythagorean theorem and how it will be used to calculate the length of your rafter.